Hi everyone, I hope you can hear me and see me okay. Welcome to this CPD webinar on Key Stage 3 computing for non-specialist teachers. My name is Liz, I work in the Education and Youth team at London City Hall, and I'm really excited to welcome all of you, no matter where in the UK you are tuning in from this afternoon, to this fifth session in our series of STEM webinars. Now, this is our first session for secondary school teachers, and the topic of this webinar is obviously computing, but we are planning more across several STEM subjects in the coming months. So if you have any suggestions or requests, please let us know later in the feedback form. A few bits of housekeeping for this webinar. Please use the Q&A panel, which should be on the right of your screen, to ask any questions that you have and communicate in this webinar. I will send you the slides and all the resources after the session, and the webinar is also being recorded, so you can rewatch and share as you wish. Now, if you experience that the picture on the stream suddenly freezes, this could be because you have accidentally clicked on the picture, which could pause it. So the solution should just be to click on it again and it will resume. I'm going to share a couple of useful links with you. The first is that we'd really recommend that you sign up to the London curriculum if you haven't already. This will ensure that you get invites to future webinars and to other events that we do. Secondly, if you are a secondary school in London, chances are high that you are eligible to get free Crest Awards from the Mayor of London. So do check that out as well. And we have a website dedicated to our STEM webinars now. So there you can see all of the recordings. There you go. And look at all the future webinars that come up. So now I'm going to hand over to our facilitator, the fantastic Sharifa Khanum from the National Centre for Computing Education. I hope you enjoy this webinar. Thank you very much for tuning in, and Sharifa, over to you.
Thanks, Liz. I hope you can all hear me. Yeah. Liz, we can hear everyone? Yeah, brilliant. Okay, good afternoon, everyone. Thank you for the introduction, Liz. So I'm going to first off apologise that I do have some building work across my road. It's quite near, actually. I live in a small cul-de-sac, so I apologise if you suddenly hear banging and bashing. It's not from my house, it's outside and I'm by a window. So quick brief background info about my experience in education and technology. I was a secondary school teacher, EST computing teacher for 8 years in London, and for the last 5 years I've been working as a consultant supporting both primary and secondary with computing and online safety. I was a programmer before and a web journalist before I became a teacher. So let's get started. So this is a short taster session of the National Centre for Computing Education. I will share with you at the end of the session how you can book and also an overview of the support available from NCCE. And I did see Janice on Q&A has put up a question about getting a certificate, but I can certainly help you later on in terms of NCCE of getting certification from there. Okay. So what will this session cover? Introduction to the 3 strands of the Key Stage 3 programme of study, what binary is and how computers use it, what an algorithm is and how to define it, and then an overview of the teaching programming using sequencing, selection and iteration. And we'll finish off the session by looking at the support available from NCCE. So the national curriculum for computing was introduced some time ago now in 2014. Many teachers are still finding it's hard getting to grips with how to teach the subject effectively. This has mainly been as a result of low teacher confidence and the lack of initial government CPD support and training to equip teachers adequately enough to deal with the subject change in direction. So statements within the curriculum can be classified into 3 broad strands that you can see: computer science, information technology and digital literacy. Be aware that these are not explicitly organised into these areas within the national curriculum itself, but most specialists and practitioners agree that the objective statements can be categorised in these areas. And they don't need to be taught in isolation, and there is an overlap between each area. I'm just going to take a pause here for 30 seconds or so. Just give you a moment to read this statement in front of you, which is taken from the Quick Start Computing. This presentation will be shared with you by Liz after the session. So, yep, and the link will be there to access the Quick Start Computing, the whole document itself. But I'll pause here to let you read. So we will focus on the computer science element of the Key Stage 3 curriculum during this taster session. So it is really important for us to look at the progression of computer science across all the key stages. Most of you are obviously probably from Key Stage 3, but it's important to look at that progression across the key stages. So the next few slides, I'm going to quickly highlight as quick as I can key aspects and the progression across the key stages. So if we start off with programming, in Key Stage 1, create and debug simple programs. This is the one on the far left. Use logical reasoning to predict behavior. Key Stage 2, design, write and debug programs that will accomplish specific goals, including controlling and simulating physical systems. Then in Key Stage 3 on the far right, use 2 or more programming languages. At least one should be textual, making it appropriate use of data structures, for example, lists, tables or arrays, and design and develop modular programs that use procedures or functions. So if we then move on to algorithm, in Key Stage 1, understand what an algorithm is, how they are used, precise and unambiguous instructions. In Key Stage 2, in the middle column, explain how simple algorithms work, detect and correct errors in algorithms and programs. And then Key Stage 3, understand several key algorithms that reflect computational thinking, sorting, searching algorithms, and also alternative algorithms for same problem, and then computational abstraction that model the state and behavior of real world problems and physical systems. Then for networks, you can see that Key Stage 1 are not expected to cover any aspects of networks, and it starts in Key Stage 2. So in Key Stage 2, understand that computer networks, including the internet, how they can provide multiple services, such as the World Wide Web, and the opportunities that they offer for communication and collaboration, and then use search technologies effectively, and how results are selected and ranked for Key Stage 2. And Key Stage 3, hardware and software and computer systems, how they communicate with one another within the system. And if we then move on to data representation, these are not introduced, as you can see, until Key Stage 3, and it will be a new topic for our pupils, and it's usually, most schools usually start teaching it in Year 8 or Year 9. So it's Boolean and or not, binary use, binary addition and conversions, understand how data of various types like images, text, sound can be represented and manipulated digitally, understand how instructions are stored and executed within a computer system. For information technology, for Key Stage 1, use technology purposefully, create, organize, store, manipulate, retrieve digital content, common uses of technology beyond school. And then in Key Stage 2, evaluate the digital content, use and combine the software, select, use and combine the software, and design, create programs, systems and content, collect, analyze, evaluate and present data and information. And in key stage 3, select, use and combine multiple applications, collecting and analyzing data, user needs and target audience, create, reuse, revise and repurpose digital artifacts, and looking at the trustworthiness of design and usability. So this strand, probably most of you will be familiar with digital literacy. This will be the final one we look at, the key aspects within for key stage 1, use technology safely, respectfully, keeping personal information private, identify where to go for help, support when they have concerns about content or contact on the internet or other online technologies. For key stage 2, use technology safely and respectfully and responsibly, and recognise acceptable and unacceptable behaviour, and identify a range of ways to report concerns about content and contact. This moves on in key stage 3 to understand a range of ways to use technology safely, respectfully, responsibly and securely, and then protect their own identity and privacy, and recognise inappropriate content, contact and conduct, and know how to report those concerns. The above statements are from the Key Stage 3 computing curriculum. I have put that link on our slide. I think it was slide 5 or so, but again, easy to access as well if you just put a Google search and put in computing program study for Key Stage 3. So for digital literacy, while we're here, it's just going to touch upon this resource if you haven't seen it. Really useful. It's the safe use of it's called Education for Connected World, and it's so important. The safe use of technology shouldn't solely be the responsibility of the computing teachers, and it is often also taught in PSHE lesson, and hopefully more so now with the in 2020, September 2020, with the statutory subject, and it is also obviously linked to safeguarding. I put the link on both of those images, so you can get the link after the session. So when you click on it for the documents there, the one that says Project Evolve, again, follows the Education for Connected World, and it has lots of resources, really great. It's in beta phase at the moment, but I would highly recommend you do have a look at that as well. And you can actually just do a search and it would come up if you put Project Evolve. So a little task for you. I'm going to ask you, use the Q&A feature, and could you just a short definition of what you think is a computer. So what is a computer? So if I give you maybe a minute for all of us just to type in what you think, please. Obviously, some of you, this might be new to you, Key Stage 3 computing. So just no right or wrong at the moment. Just put in an answer in there. There's a lot of anonymous, so there's no names for some people yet. So anonymous, thank you. Electronic device that can store press. Yep. Just give you just 30 more seconds just to see if any more contributions. Thank you for your contribution. So one definition, well, two I'm providing you here, two definition. The one on the top is from the Oxford English Dictionary, can be rather daunting, an electronic device for storing, processing data, typically in binary form according to instructions given to it in a variable program. There's a simpler one there at the bottom. A computer is an electronic device that manipulates data and it has the ability to store, retrieve and process data. Quite similar to what Anonymous has put in there, one person. Thank you for that as well. So I'm going to ask you again to get back onto Q&A. And again, it'd be really great if we can have everyone try. And I'm going to ask you to look at some of these hardware components. So look at some of these hardware components and can you identify the images on the screen? Could you add on the number and the name next to it into the Q&A box of any that you do recognise? Okay, so if you don't, but I know, I'm pretty sure there's quite a few, maybe a couple there we would all recognise. So if you could use again on your Q&A. Brilliant. I can see quite a lot of people adding in. Fab. Thanks, Rohini. I can see some more answers. So I'll give you, should we say, a minute? So maybe if I start off with 1. So if anyone has an answer for what they think number 1 would be as a hardware component. Hard drive, we've got RAM. Thanks, Joe. CPU, VDU. Okay, let's see. More answers. Yeah, brilliant. Thanks, Janice. Anonymous. Okay, let's have a look. See, so 1, hard drive. I know it does look similar to a CD drive, but there's probably some people in this in our session who probably never used a CD drive. I do remember CDs, yeah. So it's a hard drive, stores files, programs and other data. Other data when they are not being used by the computer. And good way of recognizing that that it's not the hard drive is looking at the platter. It looks very, you know, that round disk does look very similar to the disk drive. And then RAM. For the second one, random access memory holds instructions for files and programs currently open in the computer on the computer whilst they are wait to be fetched by the CPU. And then that leads us to number 3, which is the CPU, central processing unit. It fetches the instructions from memory and then executes them one at a time. And then keyboard and monitor. Keyboard collects data when the button's pressed and sends it to the computer, and then the monitor receives the data from the computer and converts it into images onto the screen. So the diagram on your screen shows the input, process, storage and output model that is within all computing systems, and the hardware that we just identified and how they fit in within this model. So you can see in input, we've got the keyboard, the data is collected and sent to the computer. Then we've got the process carrying out the instructions. We've also got the storage saving the data that is not in use, and then the output presenting the results of a processing back to the user. I have added in a link on this presentation demonstration that you can access later, really useful video from Khan Academy and code.org. It's called What Makes a Computer for further explanation, but really useful video just to start you off and also for your pupils too. So please do let me know if I'm going too fast as well. I am monitoring the chat feature as well. Okay, so what's this got to do with data? Binary. So any data, oh, I won't show that yet. Any data that a computer has to process must be converted into patterns of on-off electrical signals. This data is represented as a sequence of ones and zeros on and off. All data that we want a computer to process needs to be then converted into this binary format. So these examples here, the etymology of the word bi indicates two states on and off. As teachers, we like to link this to everyday examples. So the bicycle has two wheels, or biped has two legs, are really useful to use within your setting in your classroom. So decimal, what's this got to do with data? So denary, also known as decimal or base 10, is a standard number system used around the world. It uses 10 digits 0 to 9 to represent all numbers. Again, the etymology of the word decimal, 10 states 0 to 9, decimal number system, so 10 years in a decade, and then 10 sides in a decagon as well. So files on a computer are built from data in the same way a house is built from bricks. So the bigger the house, the more bricks that are needed. The bigger the file, the more data is needed. So binary data is measured in bits and bytes in the same way distance is measured in say millimeters, centimeter, meters, kilometers, or weights in grams and kilograms. Bits can be grouped together to make them easier to work with. So a group of 8 bits is called a byte. So you can see there, I'm not going to go through them, but again, do access this and go after the session. So binary units, making it useful, meaningful for our students. So if we look here, 1 bit, a single pixel in black and white image. 1 byte equals a single character, such as, A, M, the question mark is examples. Kilobyte, half a small email. 1 megabyte, 1 minute of an MP3 file. Gigabyte, 300 MP3 songs. And then 1 terabyte, 4 full 4K movies as well. So useful to share with pupils as it provides concrete examples to students. So the bigger, more complex files are made up of more bits and take up more storage space or take longer to load or download as well. And they will be able to relate to that. So the binary system is known as base 2 system because there are only 2 digits, like we discussed earlier. 2 digits, sorry, to select from. So 1 and 0. So when using the binary system, data is then converted using the power of 2. And we're going to look into that a bit more. So if we go back to when students learn to use tens, hundreds, thousands in primary, the decimal number representation is just a way of writing out which number to add together. We're just so used to it that we don't need to, we don't need the columns anymore. Look at the relationship between each column. Multiply by 10 to get the value in the next column along. Each column has the power of 10 higher than the previous one. There. So binary, so binary to decimal, denary numbers have a binary equivalent, and you can convert them between denary and binary. You can also break a binary number down into place value columns. Each column is a power of 2. As we just looked at, binary can only use the digits 0 and 1 or on and off. The highest we can count with 1 single digit in the ones column is 1. And the count higher, to count higher, we need to then add in another column. And if there is 1 in that column, then add the column header to the total. So look at the relationship again between the 2 columns. It's the power of 2, and these are called place values. So if we look at the example here that we've got, take the binary number 011, 00111. By looking at the place values, we can calculate the equivalent denary number, the binary representation of an even number. Also, just for you to remember, even number always ends in a 0. And an odd number always ends in a 1. So this one, 103. So I've got some one here that I think, yeah, I'll do this one, and then next one I'm going to ask you to have a go. So no, actually, could you have a look at this one and see if you can convert this binary number to denary? So if you look, see if you can convert it together, and if you can use the Q&A as well. Let's see, I think some people have already started answering. Yeah, brilliant. There's one person who's added it in. $11. So 8, yeah, absolutely. Thank you. 8 add 2 add 1 equals 11. There, let me try one more, another one. Let's try this one. So we've got the binary number 010101110. I do realise I'm putting you on the spot, especially it's a very, very short introduction to binary here for some of you. So please do just have a go. And remember, there is this is a taster. We're just quickly going through some of the session that is the full NCCE course. So please do have a go. Okay. Oh, there's a range of answers here. So we've got 64, we've got the 1 on, true, and then we've got 16, and then 4 add 2 equals 86. So again, I'm so sorry I've put you on the spot, but it's worth a try as well. And we will go through at the end of the session where you can book onto the full course and learn more about binary as well. So suggested activities to introduce pupils to binary, you can do group the students into bites, so groups of 8, print off the column header, put them on the chairs and then display the decimal number, and then students can either stand up or sit down for 1 or 0, or torches on or off, or they can write the number 1 or 0 on mini whiteboards. Really great. Students absolutely love this type of activity, and it's really, you know, unplugged activity, really useful. And again, I've put the link on there at the bottom right corner, so when you access this presentation, there's some resources that can go with this as well. So denary to binary, I've put in a link how you then convert denary to binary from BBC Bite Size. Really useful videos, both of them on 2 methods to convert a denary number to a binary number, using the binary place value method and also the divide by 2 method. So the links are there. Again, please do have a look after the session. These are the courses. So I mean, I am carrying on, but I just wanted to at this point just let you just be aware of some of the dates available for this full course from the NCCE, and I will go in more detail at the end of this session. So representing numbers, key vocab is absolutely crucial to our students' understanding of Key Stage 3. Poor use of terminology can cause problems at Key GCSE, A level, so binary base 2 system representing information, decimal denary, a base 10 system representing information, a bit pattern, a sequence of binary bits used to represent information as well. So if we move on, what is an algorithm? So again, I'm going to ask you to hop on to the Q&A, and I'd like you to put in your understanding of what an algorithm is. I'll give you a minute just to get everyone's responses in there. While some of you are typing up, I'm just going to have a look at the Q&A. I apologise if I can't answer all of them at the present moment, but the ones that I can just see now, are there any resources that can help with programming? Absolutely. I'll show you some courses and resources as well that you can go on CPD. Pattern of numbers. Some good answers. Okay, so 3 possible definitions. These are 3 possible definitions, but you can introduce it how you see it fit in your classroom with your pupils to understand. So step-by-step instructions to solve a given problem. So quite a few of you had that one, similar to that. Algorithm, a set of instructions designed to perform a specific task. Absolutely brilliant. A lot of you gave that as well. Some keywords from there. An algorithm is a set of instructions that describe how to get something done. So algorithm on the top as well. Remember, if we go back to our progression in Key Stage 1 and 2, algorithm is introduced. So in Key Stage 3, it is really useful to check people's understanding of what they know. So you can ask them, them to consider following questions, such as what makes a good algorithm? When might algorithms go wrong? What examples of algorithms have you used in real life? So when teaching pupils of algorithm, it is really good pedagogy to try to give real life examples to draw upon. And I know someone did on here, they said basically a recipe, so really useful in order to just better secure their understanding. Also, teachers could look at links with other curriculum areas, such as instructional writing within English or dance routine within PE. So really good if you can make it cross-curricular as well to have that link. Misconception time. An algorithm is a sequence of instructions for a computer. Can I ask you to again hop on to Q&A and put in yes or no if you agree? Yes if you agree, no if you don't. Okay, so we've got some answers, replies back. So algorithm, it means not equal to, that symbol there. So its algorithm is not always for a computer. So there's a two-step process for programming. First, we've got the design or created that you've created, including an algorithm. The algorithm includes the steps or rules a computer would need to follow in order to complete the task. Then only once the algorithm has been developed, it then needs to be implemented in a language that the computer understands. This is then called coding itself. Popular programming languages, someone has asked that on the Q&A. Popular programming languages in Key Stage 3 are Scratch. 3 is the latest version and it's the block-based language, and Python is the text-based language popular in Key Stage 3. But an algorithm can be implemented in variety of different languages itself, but yet an algorithm doesn't necessarily always have to be for a computer. Okay, so this extract is taken from the national curriculum, and I discussed parts of this at the start when we were looking at the progression there. So pupils should be taught to understand several key algorithms that reflect computational thinking. For example, ones for sorting and searching, use logical reasoning for to compare the utility of the alternative algorithms for the same problem. So algorithms here. You can see that algorithms are really useful for planning before the coding, like I said in the previous slide. Here we have a basic algorithm written in plain English. The algorithm has been converted into the two different languages that I said, Scratch on the left hand side, block-based language, and then we've got Python on the right hand side. For teachers currently delivering Key Stage 3 computing, can I ask you, on the Q&A, do you get your students to plan their steps before coding? So only obviously the teachers who are currently delivering Key Stage 3 computing. Can I ask you to respond on the Q&A, please? Yeah, plan. So we've got 2 people who are. Thank you. Yeah, so I would highly, if you're new, I would highly recommend do plan, but again, share the reasons on the Q&A for others as to why you do plan. But I'm going to move on. If we look at real world situations, it's a great way for pupils to think of sequentially how to produce algorithms. So the first one, we've got an example of making tea. Various ways to make a tea, but an algorithm would be good for different tastes. I'm a northerner, I'm obviously Londoner now, but I'm originally northerner, so I prefer my tea quite strong, so it would be different. Sandwich, various fillings, desired layers, again, really good way to link it to a sandwich. How to play noughts and crosses. There's also that one, I think quite a few may have come across Phil Bag's jam sandwich algorithm as well. Really useful video. Oops. So flowcharts can be used to represent algorithms in Key Stage 3. This is how you would, one method of representing an algorithm. It's a diagram that represents a set of instructions. So computing flowcharts have specific shapes for specific tasks. So we can build up more complex algorithms by gradually introducing different shapes. There are 4. So we've got the 4 main shapes. Then we've got the start and the stop. Quite self-explanatory, unless you've got a loop that, you know, there's no stop and a continuous loop. Then there's process as well, a task carried out by the algorithm itself or the computer, if it's a computer program. Input and output, so it's information coming into the algorithm or information going out to the user. And then there's the decision, the diamond shape, a question with a yes or no answer. The decision shape is the only one that has 2 lines coming from it. So one path for yes, and then another one for no. So think of quizzes like what if, what type of animal are you, etc. They usually use flowcharts with decisions, and it's a good way of introducing, again, revisiting flowcharts with your pupils. So I'm not going to go through this one. I'm just going to display it here on the screen. But this is a flowchart that shows you how to become a computer expert. The link's there as well. I've seen it in various teachers when I've gone to visit various computing teachers. They've had it next to their desk. So I'll just give you a moment to look through. Yeah. The bottom text is congratulations, you're now a local computer expert. Okay, teaching algorithms, task ideas. Some people have asked that on the Q&A. So task ideas that you can look at are give students a completed algorithm. So just to get them started, they predict the output themselves. You can also give them algorithms in the wrong order, so good with maze, moving around type of activities. Algorithms with a missing step, and then they have to go in and find it and complete it with the missing steps. Algorithms with abstracted steps, students have to produce a more detailed algorithm or instruction for maybe another pair to follow. Broken algorithms, students have to then test it and correct it. Similar but different, students are using existing algorithms to help create a new one for a similar task itself. And again, after the session, I will provide on the presentation, I'll put in the links of various websites that you can go that has examples of algorithm ideas as well, task ideas as well. So students do need to be able to compare different methods of searching and different methods of sorting. So searching for data can be very difficult. Searching for algorithms such as linear search and binary search make the process of searching for data much easier. So, you know, putting data into order can be difficult and time consuming, but a sorting algorithm such as a bubble sort and merge sort can help with this. And again, the Key Stage 3 course from NCCE, the full course, this does go into it in more detail. So again, extract from the national curriculum displayed. I'm not going to read this out just because of time. We are running short time here, so. So block-based programming. Scratch is the block-based programming environment typically used in Key Stage 2 and 3. The instructions are represented as blocks. Blocks connect together just like a jigsaw. So if you've not used it yet, they connect like a jigsaw, and they are in Key Stage 2 and Key Stage 3 really commonly used. So this one here, you can see the code when green. So Felix the cat, when he is clicked, when the green flag is clicked, it's moving 10 steps. It's going to say hello for 2 seconds and then play this meow sound until done. And then text-based program, Python is the commonly used at Key Stage 3. It requires the user to type in instructions. Although there are other program languages that can be used, typing instructions can be challenging for pupils for a number of reasons, including the need to remember commands and syntax, which is basically the structure of the language, along with difficulties in identifying errors and interpreting error messages as well. So again, there's some programs that I'm going to share at the end of this session that will help bridge that gap from block-based programming to text-based programming that you can go on. Selection, if we move on to selection. Selection is used when a decision needs to be made. So we use a selection every day to make decisions. For example, you can see some there in front of you, and we make those decisions. Our pupils are making those everyday decisions. Selection is also used when a decision needs to be made within a program. So we typically use the if command to specify a different pathway through the code, and you can see here the code will only execute if the condition is met. So if something is true, the if command does enable us to check the condition, is it met, and then if then the instructions after the if command can take place if something is true itself. Iteration. Iteration is used when computer programs repeat a set of instructions. Iteration is also referred to as repetition. Two methods of iteration, count controlled and condition controlled. Do note the forever loops. I will put them actually, I'll mention them in the next few slides. I won't introduce it right now. So count controlled iteration. So count controlled iteration does allow us to repeat a set of instructions a specific number of times. So typically use the for command for count controlled iteration, and then the count control iteration is used when you know before repeating a set of instructions how many times you want them to be repeated. The condition controlled control iteration here, you can see, allows you to control whether instructions are repeated using Boolean expressions. So it is really important that pupils are familiar with Boolean expressions before attempting to work with condition control iteration. So typically this is used a while command for condition control iteration. The code will then be repeated as long as the Boolean expression is true. So platforms, so really useful platforms that you can explore for both block-based and text-based web browser platforms, and some of them have both, so really useful. I would really recommend you to have a look through. They will be linked on the presentation when I share and when Liz shares it out to you. Do have a go and check. Particularly, EduBlocks is, it's quite a initial short, steep learning curve, but it's a nice block-based and text-based, where you can get more information. The next, Trinket as well. Trinket, I would highly recommend to have a look, but please do. I'm just not, in terms of time, we do need to move on, but I won't be able to go into detail, but the link will be there in the presentation for you. So supporting networks, this is hard, especially if you're a non-specialist teacher in computing. There is lots of support at the moment with Key Stage 3 computing, primary school computing, and GCSE computing as well. So we're going to go through some of the support that is available for not only the computing subject knowledge, but also developing your pedagogy within the computing as well. So again, just a reminder of this course, the full course. Do look at the dates, the links there for you direct that you can access after the session. So what is NCCE? So NCCE is a consortium of STEM Learning, Raspberry Pi and BCS, and they make NCCE. It was launched in 2018 and it's funded by the DFE. And the vision is for every child in every school in England to have that world-leading computing education. So some courses that I would recommend for you to go on. It's that first one there you can see, Key Stage 3 computing for non-specialist teachers, absolutely free. If you are state-funded school, independent schools, it's 220 for the whole session itself. And coming up as well soon will be the new secondary computing subject leadership, and also another course, bridging the gender gap. I'm also going to share with you these courses that come under Computer Science Accelerator program. So this program is a flexible professional development program designed to give you the subject knowledge and confidence to teach GCSE computer science. So even if you're not maybe going to be delivering computer science in GCSE, I will highly recommend you to explore and look at some of the courses, and there is certain pathways that I'm going to show you applicable for someone who's new to computing as well. So there again, and if you do go on the Computer Science Accelerator program and enroll on it, it's £920 bursary involved that the teacher will receive, the school will receive. You gain a certification as well. There's a short summative assessment at the end, but it's basically one course, one live remote course and one other course. And if you a minimum of 10 hours, and then you can get the test that will come up at the end, and you can take that certification as well and gain it. So what are the courses? So these are useful course titles for you to be aware of. All of those are within the CS Accelerator program. Highly recommend you to click on the link and have explore, look around and see what's available. Beneficial for even if you are only teaching Key Stage 3 currently. It's designed to equip subject knowledge and confidence to teach GCSE computer science, but also computing, your confidence in computing. So these pathways, you can click on the pathways as well, so you can see different pathways for the CS Accelerator program for teachers. And the one there's one for computing non-specialists, but there might be some people here who are, are new to computer science or maybe advanced already. So I would look at that, because then it will suggest which of those courses from our previous slide would be highly recommended for you to go based on your knowledge or experience. So I'm just going to, looking at the time, we have got enough time. I'm going to go through some of resources and support available from NCCE. The resource repository, there is a scheme of work, full scheme of work on NCCE. Again, the link is at the bottom. By July 2020, it will be complete. At the moment, it's more than half, lots of resources in there. There's a collection of material of up to 500 teaching materials. What comes with it as well: lesson plans, slides, homework, individual activities, progression mapping, assessment, pedagogy. Really great resources. Do have a look if you've got an opportunity. I know some of you may be at the moment, if you are computer leads, or even if you're not, you're planning for, you know, for September. This would be really useful for you to have a look through, or let your TIC or head of department be aware that these resources are available. Scheme of work. So the subject knowledge assessment would be particularly useful for you at the moment to check people's understanding, especially if they're returning to school after lockdown, so that teachers can plan accordingly. It's basically a free online subject knowledge assessment, and it allows you to evaluate your subjects, students' knowledge, and then you can use the information again, like I said, to plan for the next academic year. So do have a look again at the link provided when you've got an opportunity after this session. So I put in primary because some of you may still be also supporting primary or all through school as well. So you can also get certification and courses available from the primary as well. And there's a bursary involved with that one. If you're in a primary school, it's £220 for the first session to attend for the first teacher from your school. And then these are some of the courses that are available within the primary. So if you want to just increase your subject knowledge from the primary perspective, again, I would go in and have a look as well. So your local hubs, there's a network of up to, I'm not sure if you're aware, but yeah, there are a network of 40 computing hubs based in secondary school settings nationwide. They provide local, responsive, tailored support to all computing teachers in both primary and secondary and colleges in their area. So do have a look. And again, there is a link on that. The heading has a link for you to go and see the hubs as well on the NCCE website. The school engagement programme. So my role within NCCE is an SME, so subject matter expert. Is we support or offer fully funded consultancy and guidance to schools and colleges who meet the eligibility criteria. So, you know, if you're non-GCSE school or priority school LAD 5 and 6, then you can see I've put in the below what the eligibility is, but do have a look. You do need to go in and click on it to see in more detail. There's bursary involved for the non-GCSE schools of up to 4,000 as well. So if you are under one of those categories, so even if you're non-GCSE or you are a GCSE but recent adopters, still get in contact again, and the link there where it's a Google form where you can click in and get more information. These are just more information that you can look at what that school engagement programme looks like, and for the non-GCSE support that SMEs provide as well. I'm not going to go into detail. Please do look after this session. So these are the support an SME can support you with. There's around 40 SMEs in England. So that can support teachers in terms of upskilling, guiding courses, resources, a curriculum intent and implementation of support, schemes of work as well. We're working a lot now with Key Stage 3 schemes of work with lots of schools, subject knowledge support, infrastructure software, physical programming support, multi-school support, raising profile of the subject and raising engagement of girls as well. And there's a lot more. Again, do have a look at the website if you've got some time. So this is how you would request the support in there. So CAS communities of practice. Some of you may already be involved with CAS communities of practice. I would highly recommend for you to just go, if you've not heard of it, do go onto their website, and I would encourage you to sign up as members, because there's lots of updates on there, lots of events currently, that, you know, daily. There's so many. I was in one this morning, just wanted to attend myself. You can collaborate, network opportunities. So really recommend you do have a look at that. Volunteers, Code Club. You can go on Code Club website and request support from many volunteers on their website. All DBS check. Again, check on the link, please. STEM ambassadors. Again, you can go on to the website there, and it's free of charge resource for teachers and to engage with young people as STEM ambassadors. They're volunteers. You just need to go on the website, register, and all the STEM ambassadors also registered as Code Club volunteers as well. No, not all, some, sorry, I apologise, some. Social media, you can go on our Twitter handle and also CAS chat every Tuesday 8 to 9. Encourage you to network again. Computing, primary computing coordinators as well as secondary. For the primary, there's 2,000 members. Secondary, I'm not sure how many members there are, but really useful. Again, for updates and information. Resource toolkit. I've left the link in there for both of them. Highly, again, recommend if you haven't seen these are really good. They were developed to support primary and secondary school teachers with computing program study. They're quick start, called Quick Start Computing, provides teachers with the resources to also run CPD. So on the left hand side, but also the new the one on the right was recently, I think a few years ago, released as well, and that's for teachers focusing on Key Stage 3 to increase subject knowledge coverage. Okay, so again, please do have a look. So these are, we've come to the end. Thank you so much. So hopefully this session, I absolutely realise it was a whistle stop, you know, quick overview of a full course, but hopefully it's given you a start. We looked at the 3 strands of the computer science Key Stage 3 program of study, what binary is and how computers use it, what an algorithm is and how to define it, and then teaching programming using sequencing, selection, iteration, and then also just explored the NCCE as well. I'm going to be sticking around here with Liz, so I will look at some of the questions on the Q&A. Unfortunately, it's quite difficult when you're presenting to always look, you know, some of you may have had that already, especially if you're teaching remotely as well. But next steps, I'm going to leave this up on the screen that you can look further opportunities following on from this course, such as NCCE courses, STEM learning, courses on the FutureLearn, the online courses. Again, you can get that from the NCCE website, Raspberry Pi Foundation, and Computing at School communities and forums too. They will all be linked on the presentation. Thank you. We have gone over by 5 minutes. Thank you so much. I am going to be sticking around. Thanks, Liz. So I'm going to hand it back to you.